I'm going to give this a go. I'm going to lay some groundwork for us here. So through a series of transformation, change the graph f of x is equal to x squared into y is equal to negative 1/2 f, open brackets 2, open brackets x minus 4, close brackets plus 1. Pick out a, b, h, k. So what I notice is that a was equal to negative 1. Or sorry, negative 1/2. I have to be careful, because when you're implying transformation, this actually implies two transformation. One, I need to make the a negative through a reflection. Second one, I need to stretch the graph vertically by a factor of 1/2. So that's why I split it up like that. B is equal to 2, h is equal to 4, k is equal to positive 1. Now I'm just going to start graphing this. So hold on. Should I start graphing or should I do point notation? I'm actually going to do point notation here. So really, I start off with plane x, comma, y. And then if a is equal to negative 1, that implies a reflection upon the x-axis, which changes y or x, comma, negative y. That's how my points transform. Now I'm going to build the red describes stretching by a factor of 1/2 vertically. So really, I'm just going to take my old point and I'm going to multiply my y value by 1/2. The next thing that I'm going to do is I need to take a look at this b. And the b is really the coefficient in front of the x. But in point form, or mapping notation, x turns into x over 2, and my point still, or my y value still remains the same. So far, so good, I hope. If we have an h of 4, now what does that mean? Well, it means that I just simply add 4 to the h value. My y value stays the same. And if I have a k of 1, that means that my x value stays the same. And my y value, I just simply add 1 to it. So this is my mapping notation. Yikes. And so remember what mapping point notation is. If I have any point xy, after all these transformations, it'll become this. Allow me to start. I'm simply going to reflect my function about the x-axis. There we are. So far, so good. Now I'm vertically going to stretch my function by a factor of 2. So I just take my y values and I multiply them by 1/2. There we have it. So I have done the first transformation, second transformation. I'm sure we might get a little bit harder here. Maybe not. I don't know. So now I'm working off the red graph. Keep that in mind, not the orange. So now I need to multiply my x values by multiply the x values by a factor of 1/2, right? Because x divided by 2 is the same as 1/2 x. You can look at it that way. The words that go along with that is I compress my graph by a factor of 2, or horizontally stretch it by a factor of 1/2. Regardless, my graph sort of starts to look like ooh. Now, it doesn't have to be absolutely precise. It should be moderately, though. There we are. So we have these 5 points. Yeah, okay, so we're good. Now, that one was kind of ugly, I'm not going to lie to you. And things are getting tight in here. But this is my graph. Now, what's kind of weird, oh, never mind, I'll get to the weird part. So now I need to move my graph 4 units over to the right. And now I'm working off the blue. So 1, 2, 3, 4. I'll probably take the vertex first. And then I'm going to move this point right here. I'm going to take this blue point right here. I'm going to move it over 4 units. But I can only approximate it because things are getting a little squishy. But my blue graph, this point right here, -1, 2, I can move over 4 units over to the right. There we have it. Even this point here, I can move 4 units over to the right. And our graph is going to be all good. There. Still a parabola, and it looks weird. And last but not least, I shift each of my green points 1 unit up. So I'm going to take this point right here, I'm going to shift it up 1. I'm actually just going to look at my vertex, I'm going to shift it up 1. I'm going to shift this point up 1 and becomes that. I'm going to maybe take this point here and shift it up 1. So that's what my new graph will look like. Wow, that was a lot of work. Anyways, hopefully it paid off. It was nitpicky, but I think I learned something.